So, good morning. This is our second day of this PEARS Foundation webinar, the first PEARS Foundation webinar. Dear students, dear former students abroad, dear teachers, and PEARS Foundation grantees. For me, this is a great honor to continue the second day of this first PEARS Foundation webinar in nutritional sciences. The first day we hear the very stimulating keynote talk from Professor Elliot Berry, and we enjoy very much, and very outstanding presentations from Olumika, which I don't see her here, Francis, which I enjoy very, very much, Sarah, Lem, Mukesh, and Danning, all of them very, very good. We look forward for the talks of the rest of our students this second day, and I wish success to all of them. This second day I'm very, very excited since I want to present to you a former and excellent student of our program, Mr. Lovemore Nkhata Malunga from Malawi. I want to say several words about Lovemore. Lovemore today is a PhD student in the Department of Food Sciences, University of Manitoba, Canada, and he's there since 2011. Lovemore graduated from the University of Malawi in 2003 with BSc in Food Technology, and then he worked in several parts in Malawi. He then first came to Israel in 2007, and I think he was in love in Israel because he stayed. He attended a course in April 2007, and under the sponsorship of Mashav. And then he came back and was the part of the MSc Nutritional Sciences program from, and he completed all his work of Master of Nutrition with very nice work in 2010, and he was funded for the PEARS Foundation and from Mashav. After he finished, he went back to Malawi, and he worked in several nutrition-associated initiatives. And he wanted to improve the nutrition and well-being of children under 5 in Malawi. In 2011, he was appointed to the as a food safety consultant in the International Trade Center for Uganda and Kenya project. And now since then he's working in the British Standard Institute as a regional consultant on food safety for the Rwanda project. So far his research has been focused on exploring the nutrient and medicinal properties of crops in order to provide sustainable alternative to malnutrition and disease prevention in his country. His previous research project at the Hebrew University involved the design and formulation of an infant follow-on formula using chickpea to mitigate malnutrition among infants in Malawi. Now, as I said, he's a PhD student in the Department of Food Sciences in the University of Manitoba, Canada. And his research work looks at the role of cereal or dietary fiber in diabetes and colon cancer, which is very relevant to my research here, and the interaction between dietary iron and fiber in colon cancer. So far, he published 4 peer-reviewed scientific papers, 2 from his work here in the Hebrew University, and now 2 on his PhD work. So he's a brilliant student, and we want to hear him. Thank you very much, Lovemore.
thank you for the wonderful introduction. And before I go into today's topic, I would like to take this opportunity to express my gratitude to PEARS Foundation for making it possible for me to be here today. And secondly, I want also to express my gratitude to the Division of External Studies for making it also possible for me to be here today. And I would like also to welcome you to this webinar, whereby I will start to talk about iron and iron deficiency anemia. More especially, we want to see whether fortification would make any difference in mitigating iron and deficiency anemia. Why this particular topic today? It's because one, iron deficiency is one of the most common malnutrition disorder in the world. And secondly, we know that iron fortification is actually applied now universally. So the question could be whether that would be safe when it comes to public health or not. So when you look at the statistics itself for iron deficiency anemia, there is nothing really new, because when I was probably in primary education, we were still told the map looked almost the same by then. Two decades later, the map still looks the same, which means something somewhere is wrong. Maybe we may need to look at the different approach in fighting against iron deficiency anemia. So before we go into the actual figures, I'll give you a simple assignment. Let's say you are asked to go collect samples in a particular region. You want to know the level of hemoglobin in the preschool children. And after you do your analysis, you have this particular statistics where you find like about 70% of the children have got hemoglobin lower than 110, which is a typical indicator of iron deficiency, without having in mind the criteria of what iron deficiency is. What are you going to report back? Under normal circumstances, you assume that that should be normal blood hemoglobin level of the blood, because 70% of the population is like that. And on the other side, when you look at the population in Europe and America, you find that the same blood work is giving about majority of the population is above 110. So there could be something which at the moment, either the criteria which we are using to define iron deficiency is not accurate, or indeed the people on the other side are malnourished. So what are the main causes, let's say, of iron deficiency anemia? There are many things, but today we will look mostly at the relationship whereby the last one, where we are talking of exclusive breastfeeding beyond 6 months of age. Why particularly this one? Because it's very close to the infant formula standard. Because when you are making infant formula, you use breast milk as your standard. And at this level, we can at least identify what's actually happening. So just to understand that part, I'll just try to explain a few things about iron metabolism at that level. In the third trimester during pregnancy, we found that there is a high accumulation of iron in the fetus. And it's at that time when the fetus is believed to accumulate enough iron, which it will use for the first 4 months. So when we look at it, so we see the amount of iron which is circulating in hemoglobin here is actually also increasing as the baby is growing. At the same time, the amount of iron in the tissue is also increasing. This is not a surprise because as the baby is increasing, you're expecting the blood volume also to be increasing, so you expect more hemoglobin. And the baby is also growing, so you expect more tissue. But what is happening here, it's like only the stores of the iron is the one which is decreasing. Then there is a general understanding now that the baby will triple its weight by the end of the first year, which means the iron needs will also double within the same period. And surprisingly, what happens is on the other side, we see that the iron content in the breast milk is also decreasing within the same time. So the question is always like, why, if nature is considered to be so perfect, you would expect that as the iron demand is increasing, the iron concentration in the breast milk should also be increasing. So that brings a little bit confusion, whether the nature is trying to tell us that, okay, it's enough, stop breastfeeding. You need to look for another alternative of iron supply. So it's like we are in a dilemma. Exactly what is happening, we don't know. And actually, some scholars are believing that possibly it's an issue of evolution. And today we are going to discuss something about that component, which most of the times is not usually discussed in many places. So what are the interventions that have been done so far? Most of the times we find that iron supplementation is used. But this one mostly works in developed countries where taking of PEARS is part of their tradition. Whereas when you are looking at the developing nations, people are not used to taking PEARS. So we found that iron fortification became the closest thing that we can actually use to mitigate iron deficiency. However, when you look at the fortifying foods with the iron, it has a lot of challenges. One of it could be technological aspect of it. If you put iron in most food products, the color changes, and it affects the appealing. Many people don't like it. And at the same time, the taste itself is also horrible. So many people will not like to be taking that one. But from the public point of view, public health point of view, it's like one size is fitting everyone, which becomes a problem because in a population, as we have just seen from the prevalence data, it's like there's a lot of variation. So the concern is what would happen to the population that has already sufficient iron stores. So I'll just give you a quote from Food and Agriculture Organization in their annual report in 2000. When they are trying to summarize to see whether there have been actually progress in terms of mitigating iron deficiency. It was like, unfortunately, there have been no appreciable change over the past decades. And the important factors contributing to lack of progress include failure to recognize the actual causes of iron deficiency and iron deficiency anemia, apart from lack of political will. So just to have a clear picture on those decades, now we can just look at data from 1990 to 2010. Here we see something interesting, because if we look at Africa per se, it seems things are stagnant. I think that's the only good thing. It's not going worse. It's still like it's stagnant there. So, but when you look in Asia, Asia also it's almost the same, whereby we still see, we don't see much progress. But where we see progress is in the Eastern Asia, where we look at Japan and the other countries where their economy is actually doing well. And in Latin America, it's also the same. Those countries where economically they are still challenged, you still see that the prevalence of iron deficiency anemia still remains the same. So in this case, it brings out now two questions, interesting questions. Why is it that in developing countries, despite all the efforts, it seems we are not making any progress? And at the same time, it seems in developed countries, the same strategy seems to be working. So to have an idea probably of what's happening there, I'll take you first in the regulation of iron itself. So when we look at the iron, apparently it's one of the most regulated minerals, whereby whatever goes in rarely goes out. But whatever has to come in, the body decides. It has like tight controls on what has to come in and what has to come out. So that's why we could see that in the first example, when I was explaining about the behavior during infancy stage, we could see like the amount of iron was just moving. We didn't see any change in terms of the total amount of iron there. So there, I'll give you two scenarios. One is when you are iron deficient. In this case, we have iron proteins on the brush border. So because most of the protein that we consume is trivalent, and our body can only absorb a divalent one, so it has to be converted first by duodenocytochrome B. And once that one has been converted to divalent iron, we see now it is being absorbed through divalent metal transporter 1. So once that one gets into the cell, it is also packed back now into ferritin before being exported into the circulatory systems through the FPN. So that's how it goes the other side. So I'll not go much into the other tissue, but I just want you to understand the absorption, because that's where all the regulation is done. So when the body senses that you have sufficient amount of iron, the liver releases hepcidin to block FPN, which was the iron exporter. Then it closes the gates here and internalizes it and breaks it down. So then you have now accumulation of iron in the body, I mean in the cell. Once that happens, then the gates for the imports are actually closed. So with this mechanism, the body can only accept whatever it needs and no more. So we'll see later on in different examples whereby whether you fortify, you give somebody 20 milligram or 100 milligrams, all goes down the drain because the body will only get what it needs at a particular time. And that becomes also a challenge, even understanding the bioavailability of iron, because you have to do the study in iron deficient individuals, but the deficiency level is also different. So at the end of the day, it becomes all sophisticated to do it. So one of the examples that I want to show you during infancy, just to see whether fortification itself is actually makes any difference. We have in this study where they had like 406 infants, then one group was given 12.5 milligram and the other one was given about 1.2. And the control group, being done in Europe where cow's milk is a common practice to be given to infants, they used it. So surprisingly, you would expect that the one receiving 12.6 would have higher, much higher than even 1.2. But here, when you look at hemoglobin levels, you see even though the one receiving 12.6 seemingly has higher levels of hemoglobin, but statistically, they are not different from the other one. And if you look at the amount, this is supposed to be 10 times this one, and yet the level is still the same. And when you look to other indicator, ferritin, it's also a similar trend, showing that in this particular study, there was no difference at all between the two treatments. And importantly, I want you to pay attention to the cutoff for someone to be considered deficient. And in this case, if I follow this line, we see that in all the treatments, all the kids were just fine, despite the effort. Then in another study, in a similar setting, 92 kids, and in this case, the one group was receiving iron at 1.2 milligram, and the other one, there was no iron added. And when you look at the blood work, we see that when you look at the hemoglobin, with the red one being the one who received the fortified one, and the blue one, the one who received an fortified one. You can hardly see the difference in this case, because it seems the body was not in need of extra iron at that particular time. And when you look at the prevalence of iron deficiency, we see the green one where it's fortified, and the purple fortified. And we see also that there is hardly any difference between the two groups in terms of the prevalence of iron deficiency anemia. So this one is mostly in the developed world. So I'll just give you another example just for comparison's sake. This one in Chile. So in Chile, it was also the same between the two groups when you look at the ferritin and the hemoglobin level. But when we consider the presence of iron deficiency anemia, we see also the one with low iron seemingly had a little bit higher prevalence of iron deficiency anemia. But the most interesting part in this case was the iron deficiency without anemia, where we could actually see a big difference between those treatments. So one interesting thing about this one, it also points out to my area on when I was showing about the geographical positioning. We see that in developed countries, it seems there's nothing that fortification is actually doing. But when you look at in developing countries, it seems there is at least a difference when it comes to the prevalence of iron deficiency. What does it try to tell us before we do that? I want to share with you this particular experiment because it's one of the most cited as well when it comes to the debate about iron deficiency, whether fortification is necessary or not. What was the beauty of this experiment? Because they did it both simultaneously in a developed country as well as in a developing country. So in this case, they picked Honduras and Sweden. So in both places, they had similar treatments. So in group 1, and you have to mention that these kids were exclusively breastfed during the first 4 months. So after 4 months, the first group was given iron, 1 milligram per day for the next 5 months. Then the second group, what they did, they started giving them a placebo for the second from 4 months to 6 months. And then after that, they started giving them iron supplementation. Then the third group, they just gave them a placebo. So when they looked at the prevalence of iron deficiency anemia, you can see clearly the difference between the two populations here. If you look at Sweden, you can hardly see any difference between them. But when you look at Honduras, for example, we see that the other group is progressing really high. And even though supplementation made a difference, but the figures still look higher, which shows somehow there is a connection between the probably socio-economic status of the population with the iron deficiency anemia. So I'm taking you back to the same slide where we see also in Africa, nothing changed. Asia, same. And this side also the same. And all of them, there's one thing which is in common amongst them. It's their socio-economic status. So what could be the deciding factor in all this? I found this particular review, I think it's a nice one for you also to just to read. It gives out a different perspective on terms of evolution, that it could be something to do with evolution. And what the author is saying, that it's according to the principles of evolutionary medicine. Human milk is low in iron as an evolutionary adaptation to minimize iron availability to pathogens during weaning. So we know every organism seems to love iron because it's at the center of everything, including pathogens. So what the authors are suggesting is like in developing countries where they are likely going to face pathogens, the body automatically takes a safety position to have less iron available. In that way, you can survive a lot of infections. Whereas in developed countries, possibly because it's more of a sterile environment, the body can afford to have more iron stores. So how does this principle actually apply to it? We have to look at it this way, that when you are just feeding on breast milk, that's considered automatically as a safe product, no contamination. And 2 or 6 months, probably the body has learned through evolution that I will get complementary feeding in the next few months. So deliberately, the iron supplies starts to get lower because it is anticipating the high risk which is coming. So when you consider that the iron fortified formulas that are available on the market, for example, you'll find that their bioavailability is actually different in most cases. But taking the lowest, which the suppliers claim will be 9% of the iron in the formula will be absorbed. And we know for sure that the iron from breast milk has got the highest bioavailability, no question about that. It's a gold standard, so it was meant for that. So when you factor in the body, the weight for age, and the recommended daily intake, we find that a kid who is just breastfeeding, you see like the iron intake per day is always on the lower level, which is a perfect design for that. And for infant formulas, the kids who feed on infant formulas, because the suppliers know that iron is important, but we just don't know how much they actually need. So it's safer just to give them everything. Let them choose whatever they want and they discard the rest which they don't need. So this creates a problem if we follow the same principle. It means either we know for sure that the body tightly regulates what comes in, but majority of it will be discarded through the lumen. That's why now we are creating another burden to the lumen. Some studies have actually shown that when you look at the microbial composition of the feces from exclusively breastfed kids versus those who are formula fed, you'll find like the types of microbes which are there, they're also different. And the ones who are formula fed, they have those who like iron loving microbes, which usually are associated with being pathogens. So that could also explain that part. Then just looking at the literature, I was just interested to see what would that imply in terms of whether it can actually, whether iron itself can actually trigger some of the infectious diseases that we all know. So in 2008, one paper reported that supplemental iron does appear to increase susceptibility to malaria as measured by different parameters for you to be diagnosed with malaria. And if we go back in 1974, somebody also reported that the malarial attacks in the iron deficient group usually developed after iron therapy was started. And one of the studies which I will just explain details, just to explain other than malaria, we see that what they found was like when they had like 67 people, they just gave them a placebo, and the other were given iron. So out of the placebo group, only 7 people actually developed some infectious disease. And within the group that received iron, you can see it's about 36 people actually had something triggered. So could it be that the figures that we saw on the other side be a strategic position by the body to get ready? It is anticipating that you are living in a developing country. It's a hard there, different bugs around. So let me take a safe position. And the same, when I just looked at the WHO data, you say, for example, with malaria endemic, if you look at these two maps, they would actually look similar, except that the other one is talking about malaria and the other one is talking about the prevalence of iron deficiency. So if I have to ask you now to say whether iron fortification would be necessary, then the question probably would be the chicken-egg situation in this case. We don't know. Probably we need to address food security first in that way and clean up some environmental factors that are responsible for infectious diseases. And in that case, we'll have a clean environment and possibly we'll have a healthy population. Only then, I think it's when we can start looking at fortification, whether it's necessary or not. Because it looks, if you just jump into fortification, possibly you are going to put the whole population as well in danger. So in conclusion, I would say the importance of iron fortification possibly it's questionable, because in the developed countries, it seems it doesn't make any difference. In developing countries, it seems it doesn't make any difference other than possibly triggering some infectious diseases. So this whole thing could be attributed to the tight regulation on how the body is trying to manage iron absorption. Then if at all, I know some of you'll be on the advisory committees on the nutrition. In developing countries, iron fortification, I would still recommend it has to be approached with caution, because we don't know until maybe further research is actually done to see, to screen out the possibility of triggering infectious diseases. And as I said, addressing food security and other environmental factors to ascertain a healthy population would be the way to go prior to thinking of fortification. And before I conclude, I just want to reinstate to acknowledge PEARS Foundation, the Division of External Studies, as well as the academic co-chairs for giving me the platform to be here. Thank you.
Thank you very much, Lovemore. And any questions?
Thank you. Thank you very much for your talk. It was very interesting. As for possible methods to control this issue, you mentioned increasing food security and environmental factors. Do you think, though, that that's going to have an, maybe not an immediate effect, but a very quick effect on how the body reacts to iron? Because since you talked about from an evolutionary standpoint, wouldn't it take a few generations for that to be balanced, or is this something that can be easily adapted?
No, it will take time for sure, because if we bring in like evolution, the body will still be cautious, will still maintain the safe levels until some time when the body, as I'm saying, it could be not probably an evolution, it could be like the body has sensors in the GI tract which sends the message. You know, it's like the GI is a bit more complicated than what we understand. So if it's not from evolution point of view, if it's just a question of sensors, it can bring in immediate change. But if it's a question of actually to go through the genetic modification and everything, then that one might take maybe 2 generations or so.
Sanitation, I think we heard at some point sanitation makes the difference.
Yeah.
And also, I think it's just installing wash-up rooms in schools in Africa make the change for almost every disease and everything. So, yes.
Lovemore, thank you for a wonderful talk. I really enjoyed it. I think it's an eye-opener. What I wanted to say, and it's not really a question, but I think we have to remember that in medicine and nutrition, the first thing is do no harm. And I think we all have good intentions, and we see low levels of iron, and this goes for all kinds of supplementation, and we start throwing vitamins at people thinking that we're helping. And I think we have to be much more cautious when we talk about fortification, supplementation, and have good evidence-based that we're actually doing, we're actually helping the situation. Because it was very interesting to me to hear this talk. It was definitely an eye-opener because we're so, that's the first thing we think, that we need to give supplementation, give good formulas, and maybe that's not the right way to go.
Yeah, thank you.
Well, thank you for the talk. It was very interesting. Actually, I wanted to ask the same. To your opinion, if we can extrapolate your conclusion to all micronutrients, you think we can say the same about the addition, supplementation of calcium, of vitamin D, or is it specific to iron? What do you think?
I think it can be extrapolated to other micronutrients. It's only, for example, I'll give you in particular like zinc, because zinc and iron, usually they are the two important micronutrients, but at the same time, they are the two which have been completely misunderstood because they are just found everywhere within the biochemical interactions. So it could be more of them, we still don't understand them. And they could be, if you look at the map itself, it's like all of them, they're also common in the same region, right? And in the Western world, they are not there. The deficiency is on the other side. That's why I was saying possibly we are reading the data from the other point of view. We are supposed to be looking at those people whom we are considering to be iron deficient should be iron sufficient in those particular regions. It could be something like that.
Any other questions? Thank you very much, Lovemore, for your nice talk. Now we are all ready to hear Fiorenza, and she will talk about changes in childhood food consumption patterns and its relation to bone development. Please.
Okay, so thank you very much for being here. Thank you everyone that's watching online. And today I'm here because I wanted to show you my findings on my research exercise. The name is Changes in Childhood Food Consumption Patterns and its Relation to Bone Development. My name is Fiorenza Corte, I'm from Mexico. And this study was done by the supervision of Professor Efrat Monsenago-Ornan here in the university. I wanted to give a special thanks to the Mexican Foundation Friends of the Hebrew University for making it possible for me to be here. Okay, so first of all, I wanted to give you a little bit of an overview to talk to you about what we are going to see today. We have seen that changes in children's eating patterns and lifestyle have led to an impairment in factors that will determine this bone mass in children, such as intake of key nutrients being too high or too low, and hormonal changes that children will undergo during normal puberty. And this will make it unable to reach the peak bone mass during childhood and young adults, that it will lead to an early bone loss, fracture risk, and osteoporosis later in life. So I wanted to start also with bone metabolism. And the bone is a highly specialized and dynamic connective tissue that will give support for muscular activity, physical protection for internal organs, and it's involved in the systemic mineral homeostasis acting as a mineral reservoir for calcium and growth factors. 99% of the calcium in the body, it will be stored in the bone, and 1% in fluids. So when we talk about bone and growth, we can't leave out bone remodeling, because bone remodeling, it's a lifelong process where old bone is removed, and that's called resorption, and new bone is added, it's called ossification. And this process, it's a continuous process during life, and it undergoes by remodeling units called osteoblasts and osteoclasts. So first of all, the osteoclasts are the only cells in the body that are able to resorb the bone, and they are the first one to get in. They will do their work, and they will resorb the bone, liberating mostly calcium to the circulation. Then osteoclasts will be removed, and the osteoblasts, the only cells in the body able to form the bone, will come and mineralize the matrix, and leading to a bone formation. Why is it so important? Because if we're talking about when we're talking about a mineral reservoir, we have to say that it's exchanged. It can be just stuck in the bone. That's the first function. And also, this is the only way the body knows how to repair the maker damage and the fractures. During life, this cycle is very controlled. During young age, modeling will dominate, because we need to lead to an increase in bone size and bone mass. After that, in young adults, we will call it a balanced process, because the resorbed bone, it's going to be equal to the newly formed, and this will last approximately 20 years until we're going to reach the age of 50 years old. After we're 50, the resorption will predominate, and the bone mass will begin to decrease, leading to bone loss. This is a normal process, and it will occur with age, to every individual. That's why it's really important to reach this peak bone mass during this early stage in life. Peak bone mass, it's the maximum bone mineral accumulation. And when we are talking about maximum, it's better to call it optimal, because even if we have a too high or a too low bone density, it's as bad to health. So the bone mass, in a lot of studies, evidence showed that bone mass will not widen with age, and a person's bone mass at the age of 30 will be at its maximum point. There will be some factors that will determine this bone mass, and we can see that 70% of these factors will be genetic, and it will depend on the phenotype of each person. But we have also a 30% window of opportunity to make a preventive strategy to determine this bone mass, and this will include hormonal changes through life, nutritional factors, and lifestyle. With these graphs, I wanted to show you also the difference between gender, because this was a study published in the Clinical Cases in Mineral and Bone Metabolism in 2013, and it's showing us how women or females will react different than male. At the same, when we have in the X line the age, in the first graph we're showing velocity. So bone mineral content, the velocity in females will be before. Why? Because of menarche. And why? Because of steroid hormones. After that, this will be at between 12 and 13 years old. When comparing to males, they will reach a higher velocity, and it will be around the age of 15. In the second part of the graph, I wanted to show you how the difference between the bone loss between gender, it's also very important. Because the dotted line, it's showing us the females, and we will have number one stating the peak bone mass at the same age, at the age of 30 approximately. And after that, they will have a bone loss during the menopause because of the contribution of these steroid hormones and estrogens. And the third point is showing us the bone loss with age. Comparing to men, they just have the bone loss with age, so this is beneficial for them. So when we talk about the regulation of bone growth, it's a very controlled process, and it depends on hormonal factors and growth factors. To see it like in a big scale, I wanted to start talking about growth hormone, that we know that it's have growth promoting effects on almost every cell of the body, and the bone, it's no different. And this will stimulate the osteoblast activity, and we know that the osteoblasts are the cells that are capable of form the bone. Also, growth factors are really important, and I really want to make an emphasis on IGF-1, that's insulin-like growth factor. This is the primary mediator of growth hormone, and it will have a direct effect in the number and the function of the osteoblast. And it's known to help with bone elongation. And IGF levels, it's also really important because it's a marker of undernutrition in patients. Insulin, we know it as a hormone, but it also have growth factors, because recent studies show how insulin receptors are expressed in the osteoblasts. And when the osteoblasts are exposed to physiological levels of insulin, this will lead to have anabolic like an increase in anabolic bone markers. The steroid hormones will be a crucial element for bone growth during the puberty. Androgens will control growth hormone before puberty, and it will be related to bone elongation, longitudinal and radial. And estrogens will be, they will directly work on osteoblasts. They will increase the number of osteoblasts, but they will also diminish the resorption. So this is very important. Thyroid hormones, T3 and T4, will also work on the osteoblasts, and they will increase the synthesis of IGF-1. So we can see that everything will work together. I don't want to leave out the key nutrients in bone development. We have a lot of key nutrients such as calcium, vitamin D, vitamin K, protein, zinc, phosphorus, and magnesium. And when we have an adequate intake of all of these micronutrients, we're going to have a positive effect on bone remodeling, calcium retention. We're going to diminish the age-related bone loss and fracture, and we will prevent deficiencies. With this figure, I wanted to show you how it's a very complex process and how everything will work out together. Because when we have a decreased essential nutrients in the diet, this will have a negative effect on the bone formation, and it will have a negative effect at the same time to the IGF synthesis in the liver. The IGF, we saw that it was going to be a positive effect on the bone with the osteoblasts. Also, leptin, that it's a hormone that it's usually we just thought about it as a suppressor of appetite, but also we've shown that we have leptin receptors in the bone that will help the osteoblast proliferation and maturation. And in obesity, we're going to have a resistance to this leptin, and this will also lead to an insufficient bone formation. We have other type of components such as caffeine that will have a negative effect on the bone, and glucose having in an increased levels also a negative effect on the bone, but a positive effect on insulin. And we saw how insulin had a positive effect on the bone. So you can see that everything works out together, and it's a very controlled process in life. So now we're reaching to the changes in children's eating patterns. In the last 30 and 40 years, a lot of changes in the eating patterns of children have happened. The first one, we have a high consumption of fast foods and carbonated drinks. We have bigger portion sizes. We have added sugars and fats in industrialized food. We have modern eating environment defined by time limitations. We have now working parents that do not have the time to prepare like home meals, and they were going to use industrialized food, contributing to this addition in sugars and fats in children's diet. When we add this to less active lifestyles, we're gonna not only have like a negative effect with obesity. This will increase the obesity, but it will also decrease bone formation. And also in recent studies, they have shown that an increase in lactose intolerance worldwide have been shown, and this will promote the avoidance to dairy products. And we know that 25% of the intake of calcium in children's diet comes from milk. So this is also will be a risk factor for osteoporosis. Adult chronic diseases will originate during childhood, and this will lead to a higher morbidity and mortality later in life. And the main cause for this predisposition will be chronic diseases. For chronic diseases, it's overweight and obesity in early years. In the National Health Survey in the United States, in 2012, we saw that 17% of US children are obese. These are 12.5 million children, so this number is very high. And it has changed since 1980. We were around 5%, now it's 17%, and in adolescence we're reaching 20%. one of these changes, so the percentage of energy intake from food that is consumed at home had lowered, and by the other way, the percentage of intake of food eaten as fast food in fast food establishment has gone up. We have lost approximately 10% of the food intake at home, and we have increased another 15% our fast food intake. This will lower the quality and the quantity of the nutrients that are involved in bone development. With this paper that was published in the International Journal of Obesity in 2001, I wanted to show you how 75% of the adolescents said that they ate at a fast food restaurant in the previous week, and how this will contribute 40% to have a higher energy intake from those who did not. So these numbers are extremely high as well. So when we're talking about bone health, how obesity is related to bone health? Some studies have shown an association in two different things. The first one is body size and weight. When we have a higher body weight and obesity, we will have a lower bone mineral content and bone mineral density, and it will promote fracture risk in children. But also when we have a high body weight, we will also have a greater fracture risk. So this is telling us that we really need to make emphasis on having a normal BMI in children. And the second part is body composition, because at the same weight, we've seen when we have an increase in lean tissue compared to fat tissue, we will have a higher bone mineral content and bone mineral density in children and men adults, not to women, because the adipose tissue will function as an endocrine organ after menopause for women. So the intake of key nutrients are too high. When they are too high or too low, they will make us not achieve a normal bone growth and development, and this will promote an unhealthy outcome later in life. And when we talk about unhealthy outcomes, when we talk about bone, we can't stop mentioning osteoporosis, that it's a skeletal disease characterized by low bone mass and a deterioration of bone tissue, with a consequent increase in bone fragility and fracture. The World Health Organization in 2012 stated that 10 million individuals in the US are living with osteoporosis, and 34 million added have also a low bone mass, increasing also these figures. We talked about the increase in the carbonated drinks, and I wanted to relate this to bone health. And the way it's related is because it has an impact in the acid-base balance of the body that will show a relation between dietary components and how they will contribute to the acid and the alkali load in the body. So we will have these two contributors. The acid load, we will have foods rich in sulfur amino acids, phosphorus and chloride that are found in meat, grains, nuts, and dairy products. And into the alkali load, we will have potassium, magnesium, salts of organic acids, and that they will be found in fruits and vegetables. And how will this work on the bone? In a few simple words. When we have an increased intake of carbonated sugary drinks, a part of their contribution in obesity, they have a contribution to the acid load, because they have a high acidulant level, and the body will have to make a consequent buffering action that it will be deliberated from the bone into the circulation, promoting bone loss. Lactose intolerance, a very important issue also. It will be associated with a low calcium intake because of the avoidance of milk and milk products, because we saw that this is the main source of calcium in children's diet. And well, the lactose intolerance are some individuals, when they ingest this lactose, they will have abdominal symptoms because they are lacking the enzyme lactase that will break this lactose in the organism. This is another study that I wanted to show you in 2012, that it compared children who drank cow milk and how it was their dietary calcium intake and their poor bone health. So they were drinking approximately 450 milligrams of calcium a day. This is very low. And when they made the measurements, they were all significantly shorter. They had higher BMIs, they had smaller bones, and they had lower body mineral density at all regional sites compared to the ones that they are drinking cow milk, with a p-value lower of 0.01, showing that it's very significant. So to conclude all of these things that we have talked about, there have been changes for sure in children's eating patterns, and this is contributing to the rising epidemic of obesity that will lead to a higher risk of the appearance of these chronic diseases later in life. And this will also contribute to the bad quality diets and contributing to the macro and micronutrients deficiencies in the body, and children are a very susceptible part of our population. And some of the deficiencies will contribute to an impaired bone growth and development, leading to an unhealthy state later in life. So what we really see is that we have a lack of effective treatment for these degenerative diseases, such as osteoporosis. So we should have think about making an emphasis on these preventive strategies, including dietary approaches. And I wanted to tell you that it's really important to consider osteoporosis as a pediatric disease with geriatric consequences, because we have this peak bone mass, that it's our gap of opportunity and our window that we can improve during this early stage in life. And an emphasis should be placed when we're making all of these strategies for public health to a better understanding of how the role of diet and nutrition will have on the bone. Thank you.
Very nice talk, Fiorenza. Questions?
Well, Fiorenza, first of all, congratulations. It was a pretty interesting talk. And I am a little bit concerned because what are we going to do? Like, it seems that the current behaviors in children, they are getting worse instead of getting better. So what strategy do you propose for avoiding this, or to treat or to stop it, or to treat the disease?
Okay, I can think about mainly 3 points that are really important, because this, as all of the degenerative disease, they are multifactorial. You know, we have to look in detail to a lot of things in order to make an impact. The first one, I would say that children are a vulnerable group of our population because they depend on their parents. So the first thing that I would say is that you have to start changing the eating behaviors from the parents, so they can show in early stages in life how to have a proper eating behaviors. And when we grow older, it's so hard to change these behaviors. It becomes harder. So if we teach the children how to eat properly during this early stage, it's going to make it a lot easier for them to maintain them during life. The second part, I think that it's really important to see how physical activity it has a major contribution to obesity and to bone growth. So when we promote a better, a less sedentary lifestyle, we will decrease the levels of obesity, and this will have a direct effect on bone formation. That it's also really important. And when we have these particular cases, I am sure that we can complete and achieve the DRIs just to having in a good quality diet. But when we have particular cases of lactose intolerance, they should be maybe seen with a dietitian or a doctor to have a careful supplementation in children, so we can really secure this period in time toward the peak bone mass. I would think it's big, but I think we have to separate it and do it little by little.
Thank you.
First of all, congratulations, Fiorenza. It was very interesting. And I wanted to ask you, you were discussing about the importance of the acid and base load, that the body needs to regulate this, and so we should promote a balance. What would you say about the vegetarian diets, where meat and these sources of acids are lower?
Yes. For these diets, I think that you should have to start thinking about first the type of the diet, because when we said vegetarians, we have to make a distinction that we have vegans and we have vegetarians. So we will have contributors on the diet that will contribute to this acid or alkali load. And when we talk about a vegan diet, we're talking about exclusively taking out all of the food that's coming like animal sources. So they will maybe have like an increase in in the intake of other foods such as vegetables and fruits, that this will contribute to the alkali load of the body. But when we talk about vegetarians, where they're going to eat egg and they're going to eat cheese and they're going to have milk, the contribution to the acid load will be the same. So I think we have to make a different separation between these two, saying that maybe we should have like a closer look at this subject, but maybe we're going to make it beneficiary to the alkali load if we have just an increase in the amount of vegetables and fruits in the diets. So also this, the amount of each of the macronutrients and their balance will contribute to this acid load. So we have to see it like in a very particular way.
You want to ask something? No. I would like to ask, what do you say? This is in the developed world, in the Western world. Most of the reports that you have found. What you think? What happens in the developing world? If you can see several trends, or you can have you can give them similar outputs to the developing world.
Yes. For this question, I wanted also to make a little bit of emphasis. Yesterday, Sarah was giving us a presentation about how all of these diseases are affecting the same way to poor and to rich peoples and countries. So I think the output will be the same, because when we talk about malnutrition, we're talking about high and low. So I think in order to have this balance, it's the same output, because it will affect, when we have too much or too low, it will have a negative effect on bone, on both of them. So, and the trendings in developing countries, their obesity levels are extremely high, because the source of their food, it's not good, because of the cycle of poverty that they're in. So I think it's the same.
Okay. So if we do not have any more questions, we have now a break, and then we will continue. Thank you very much.
Thank you.